Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about static routing algorithm. In previous sessions, we already discussed routing algorithms are divided into two types, static and dynamic, that is adaptive and non-adaptive, static and dynamic. Today, we are going to discussing about static routing algorithms. Let's see the overview of today's session. In static routing algorithms, that is called as the non-adaptive routing algorithms. Data algorithms are the shortest path algorithm, flooding and flow-based routing algorithm. These three algorithms we can call it as a static routing algorithms. We have to discuss all these algorithms in today's session. First, let us see what is shortest path routing algorithm. Shortest path routing algorithm is nothing but Dijkstra's shortest path routing algorithm. So, how we have to use this routing algorithm? First of all, first it can start with the local node, but that is the first node. That node is nothing but root of the tree. Assign a cost of that particular node. Whenever we are starting this particular node, this node is nothing but the starting node. The cost of that particular node is 0 to this node and make that is the first permanent node. Whenever we started from that particular node, that is the first permanent node. Examine each neighbor of that particular node. That was the last permanent node. Means each and every node we have. Suppose if after this node we have go to this node. If we go for this node, this is the last permanent node. This is A, and from A to B if you want to travel. So this is the first node. This is the last node. If we visited that particular node, that is the permanent node. Assign a cumulative cost to each node and make it as a tentative. Whenever we reach that particular node, that node is nothing but the tentative node. So among these all tentative nodes, first you have to find the smallest cost. Suppose here is the B, here is C, this is the router C. If I want to go from this router A to router D, this is the source, this is the destination. Source and destination. From source to destination I have to travel. So first you have to find the node with the smallest cost to make that is as a permanent. Suppose if I want to go from this A to D, two routes are available. A to B, B to D is also there. A to B, B to D also there. A to C, C to D also there. So in that, here we have to give the cost. 2, 3, 1, 4, 1, 5 is there. So here, first what we have to do? We have to select the smallest cost. From A, here, it is the neighboring nodes are B and C. From B and C, which one is the least cost? Which one is having the less cost? That is one only. From A to C, we have to select first. So here we have to select it. That is the permanent node. Then we can mark it as like this. If the node can be reached from more than one route, then select the route which one is the shortest cumulative. How it is going to be happen? Suppose here the cost is still here 1. After this, if I want to go from C to D, that is going to be what? It is going to be 6. Means 1 plus 5 equal to 6. Here the cost is going to be 5. So coming to here the B is nothing but A to B is what? 2. Here is 2. But 2 plus 3 from B to D, it is going to be 5. Means this is the, means which one is the shortest one? That one we have to take. 2 plus 5 is, 2 plus 3 is nothing but 5. Means from A to B, B to D, we have to select. That is the best route. Because the total cost is 5 only. Here the total cost, if we go for this route, the total cost is 6. That's why we have to go for the shortest cumulative cost. Repeat the total steps 2 and 4. Whatever steps are there, these two steps 2 and 4, we have to repeat those steps until reaching to the permanent node. Means reaching to the destination, we have to follow these steps only. So how it is going to be happen? We have to see with one example. First we have to select. This is the example. See here. Here A is there. It is the source. Here D is there. We have to transfer our packets from A to D. How we have to transfer? For each and here B, C, here D, E, G, F, H. These are all called as the routers. A, B, C, D. All these are called as the routers. From A to B link is there, right? A to B. This is nothing but the link. Whatever is this is nothing but link. This is the link. So B, A, B, C, D, E, F, G, H. These are all the routers. From that we are going to transfer the data from A to D, source to destination. Our source is A. From A to we have to transfer the packets to the D. Destination is the D. How we have to transfer the data using the Dijkstra's shortest path algorithm. First, whatever node is there, whenever we are starting, that node we have to, whenever we visited some particular node, we have to mark it as a dark. That is the visited node. So from that, from A, what are the neighboring nodes are there, we have to check first of all. B and C are the neighboring nodes for the A. So each and every node, each and every link is connecting some cost. So here A to B is 2 is there, A to C is 6 is there, B to C is 7 is there. Like that we have to give the cost for each and every node, means the distance. We can call it as a distance. If I want to travel from E to F, the distance is 2, like that. If you want to travel from C to H, the distance is 4. Like that we have to give the cost for each and every link. So here, what are the neighboring nodes of A is nothing but A to B and A to C is the nodes, right? These two are the neighboring nodes of A. So the cost of A to B is 2. The cost of A to C is 6. Yes or no? So in that we have to select the shortest distance, shortest path. Which one is the shortest from 2 and 6? It is the 2 is the shortest one. So we selected 2 as the next node. That is the visited node. Next node from A to we are going to 2. But what is the final destination? We have to reach to the D. From that we are going from A to B we started. So because the shortest distance from A to B is 2. That's why we selected. So remaining all nodes we have to allocate it for infinity. We don't know all other nodes cost. That's why we are at A only. So we don't know other nodes. That's why we are giving all nodes as the infinity. That is the condition. So that's why we are giving infinity to each and every node. So because we don't know the cost of that particular router. So we are at this particular node. This is the working node. Here the cost is 2. Till here the cost is 2. Suppose if we go for this node, if we go for G, the cost is what? Here is 6. A to G, what is that? Here the cost is 6. So next one, after B, here is the first, here is the shortest. From comparing 2 and 6, which one is the shortest? 2. That's why we are in this node. So here B neighboring nodes are, what are the B neighboring nodes? C is there as well as the E is there. Which one is the best one? C cost is how much? C is nothing but here is 7 is there, and B to E the cost is 2. Which one is the best one from 7 and 2? Obviously that is 2 only. 2 plus 2 is nothing but what? 4. That is only, here we wrote 4. So we visited E. That is the next permanent node. And next, after reaching to the 4, next, what are the neighboring nodes of E? So already here the cost is 6. What here is suppose A to G the cost is 6. That's why here we wrote 6. From E to G the cost is how much? E to G how much? It is 1. In the first it is all we did. All cost is going to be indicated in first one. A. Here we indicated all. So here E to G is nothing but 1. So that's why from E to A neighboring node, next neighboring node here also there, right? E to F is called 2. Here if we go for this 4 plus 1, here it can be updated with the 5. This 6 is going to be updated with 5. Because the shortest, here is 6 is there, but 4 plus 1 is 5. That's why the 6 is updated with 5 here. That is the G node. So next here 4 plus 2 is 6. That's why here it is going to be updated with 6. That is the F node. So till here we are there. So which one is the best one? 6 here, 6 is there, here 5 is there. Which one is the shortest? 5 is the shortest. That's why we are selecting G node. Next one is the G node. That is also working node. That is the next working node. From that 5, what are the neighboring nodes? Already this one is visited. No need to go that route. What is the next node here? G to H. What is the cost here? 4. Here we wrote 4. Here 5 is there. 5 plus 4 is 9. So here we wrote 9. That is the condition. So the next node is H. So from F, we are visiting all nodes first thing. So from H, if we go for C, what is the cost F to here? F to C, that is 3. F is 6. Here is 3. 6 plus 3 is 9. Here is 9. Here is 8. Which one is the best one from 8 and 9? Which one is the best one? That is 8 only. That's why we are taking this route. From H to D, what is the cost here? D. 2, right? That is 2. 8 plus 2 is nothing but 11. Here we wrote 11. Suppose if we choose this route C to D, here is 9. Here is 9 plus 3. Here is C to D is 3 is there. So 9 plus 3 is how much? 9 plus 3 is nothing but 9 plus 3 is 12. Here 8 plus 2 is nothing but 8 plus 2 is nothing but 11. So which one is the best route? This is the best route. So that we are taking whatever elements are there, that we have to select. First we have to go for A. Afterwards where we went? B. From B onwards we went E. From E onwards we went to G. From G onwards we went to H. And from H1 onwards we went to D. This is the shortest path from sending the packets from A to D. Like this, we have to consider the shortest path algorithm. This is the example of the shortest path algorithm. And next one is the flooding algorithm. This is the second one in the static algorithm. See here, it is another static algorithm. Every incoming packet, whatever incoming packet is there, that can send out to every outgoing line except which it is going to be arrived. Suppose this is the sender and receiver. See this example. Here is the source. This is the source. If you want to send the data, flooding is nothing but what? Except this particular node, which it is going to be arrived on, it will send to all other nodes, which is neighbor to these all nodes, it will send to all other nodes. That is the flooding. Whichever routes are available to this particular router, it will send the data packets to all other routers is nothing but the flooding. This flooding is generate the vast number of duplicate packets. How it is going to be generate the duplicate packets? See here. So I am sending the packet here. I am sending the data. This is the source. Suppose consider this is the destination. This is the destination. If I want to send the data from this source to destination of this particular packet, first it will send this route. Afterward, it will take this route. Till here it is reached. Suppose this packet is sending to this route, there may be duplication of this packet because the data is already sent to this route. Again, we are sending that packet using this particular route. That's why there may be duplication. Vast number of duplicate packets are there in that particular flooding concept. In fact, an infinite number of packets are going to be there. The main disadvantage in this flooding is what? Duplicate packets. Where we are going to use this particular flooding concept? In military and distributed databases, we are going to use the flooding concept. The main thing is flooding means we are sending the data packets to all other nearest neighbors. That is flooding, whichever except which it is going to be arrived on. That is the flooding. So how we have to stop this, eliminate the duplicate packets? We said the main disadvantage is what? Duplicate packets, right? How we have to eliminate those duplicate packets? The first thing is using hop counter we can eliminate. How we are going to give the hop counter? Suppose this is the source, this is the destination, right? If you want to send the packet, suppose if we give the hop counter here is 3, we have to decrease each and every time. So if it is 3 means next node, if it is the next node, the hop counter is 2. If it is the next node, the hop counter is 1. If it is the next node, the hop counter is 0. Where the counter is going to be there, we have to discard the packet. We have to stop the packet. That is the hop counter method. And next for eliminating the duplicate packet, sequence number for each and every packet. We have to give the sequence number. Suppose if I am selecting the one packet, if I want to send the packet, that packet, if I one packet 1, 2, 3, 4 like that packets are there. If I want to send the data, we have to give the numbering for that which route, which packet is going on. From this route, suppose if you select this route, which packet is going on. Like that, we have to give the numbering for that particular packet to avoiding the sending of the same packet in the second time, because we are giving sequence number to each and every packet. That's why we are avoiding for sending the same packet second time. That is the sequence number use. And next one is the keep in each router per source of the list packets already seen. Suppose for each and every route we have to give the some table which packet arrived, which packet is arrived. Here 2 is arrived. Next suppose 3 is going to be coming in this route. 3 is arrived. Like this we have to give some router table which already visited. That is the sequence number in the packet. And next one is the selective flooding. Use only those lines that are going to be approximately in right direction. Means suppose if we want to send particular packets, we have to go that particular direction only for sending the data. That is nothing but selective flooding. Means we are selecting only one route for sending the packets. That is selective flooding. These are all for the eliminating the duplicate packets in the flooding concept. And next one is the flow based routing. This is also one of the static algorithm. See, mainly it is talking about it mainly used in the topology, based on the topology and the traffic load condition. We are deciding the route. Means which route traffic is there, which route at the same time which route is the best route. That is the based on these two conditions, we are going to allocate the package to that particular route. See here, use this technique flow based routing. The following information should be in advanced. What are the three techniques we are going to follow in flow based routing? First one is the subnet topology. What is subnet topology here? Subnet topology means topology is nothing but what? Physical arrangement. Means it is the source, here is the destination. Right? Here is the source and destination from this particular route. From this means subnet topology means what are the available routes are there. What are the available routes are there for sending the data. If you want to send the data, if you want to send this particular packet, what are the routes are available for sending the data to this destination. So here number of routes are there. Number of routes are there for sending the data, right? That is the subnet topology. What are the available routes are there? Traffic matrix are there. Suppose number of routes are there, that is okay. Which route is having the more traffic? Suppose if we consider this route, this is the full of traffic. This is the full of traffic. Next, we have to go for the least cost next one. That is the traffic matrix. Means if this route, they don't have any traffic, we can choose for this route. That is the traffic matrix. Line capacity matrix based on the bandwidth. Which line we can to select? Because based on the bandwidth, we have to select which route is the best route for transferring the data to that particular destination. Based on these three conditions, we are selecting that particular route. Based on the topology, means physical arrangement. That is, next one is the traffic. Based on the traffic, which route. Suppose sometimes sender to source to destination, this route is the best route. This route is the best route means it is having the shorter distance. But here the traffic is more. That time what we have to do? We can go for the another route. Here there is no traffic. There is no less traffic is there. But here the distance is more. Sometimes we have to select this route. That is the flow based route. Based on the topology and traffic, we are selecting the best route. That is the flow based routing algorithm. So coming to the summary, today's session we discussed static routing algorithms. Those are the non-adaptive routing algorithms. In that we discussed what is shortest path algorithm, Dijkstra shortest path algorithm. Next we discussed what is flooding, and next how to overcome the flooding. Next one we discussed what is flow based routing algorithm. These all are comes under the static routing algorithms. Thank you.